to go over that and also to talk about the final. So, final exam will be available Saturday through Wednesday of next week. So this Saturday through a week from Wednesday. I'll post more information about the final during the week of 12/2. I might post something, but I'm definitely talking about something today. All assignments, tests, etc. must be turned in no later than the end of day 12/11. Nothing will be accepted unless we've agreed prior to that. All right? And any request for an incomplete needs to be made prior to that. And to receive an incomplete, you really need to show that there were circumstances beyond your control that prevented you from finishing the material. And if you think you're eligible for one, we need to talk about it. We need to talk about it prior to that day. All right? There's no classes. My class won't meet the week of 12/9. Okay? So I don't have class. I don't have formal office hours during those times either. All right? So that doesn't mean I'm not going to be here. And that doesn't mean that I can be here if you need me during a certain time. So if you do need me, the best thing to do would be to contact me as soon as possible and say when you need me here, and I'll make every effort to be here during that time. The further in advance that you give, the more notice that you give, the more likely I'm able to comply with your request. All right? So that's that. Let's talk about the final. And maybe as I make a final, I'll make a review guide. So I'll take notes for you guys. All right? So let me go in here and let me go. Probably as good as anything to do. All right, the idea of the final is, how do I want to say it? You've shown your programming ability by the programs that you've written throughout the course. Okay? So you're not going to be requested to write an entire program that does something. You may be requested to write parts of a program. All right? In other words, what is the statement to do this? What is the statement to to execute this line, check for an exception, and display such and such message if there's an exception? So that's just like a snippet. That's not what I'm thinking about when I'm saying you're not going to write a full program. You might write portions of a program. All right? So first of all, let's go and edit this, and I will say final will consist of concepts and writing code snippets. I think that's a good example and not whole programs. Write a function that does this as an example of a code snippet. All right, so you're not writing a whole program, but maybe you are writing a portion of a program that you can use. All right. The idea is this, and this is as I said before, you've had a lot of programming examples. So the final is really going to be to make sure you understand why you do certain things. Because I could tell you, for example, write code to check to see if this number is negative and throw an exception if it is. And you could write that. But understanding why you would do that instead of doing something else might be, why do you bother throwing exceptions or whatever? That's the kind of thing that I want to test. What are the purpose of exceptions? When might you use them? As opposed to telling you something and then expecting you to write the code. So understanding purpose of exceptions is one thing. All right. Another thing is constants. Why you would use them and how you would use them. All right. We talked about a way to make a constant. And we talked about why to use them, and we talked about how you would use them. All right. Interfaces. I don't mean graphical interfaces. I mean the Java concept of an interface. Why we use them and how. Maybe even think of an example of an interface. Boxing and unboxing. We talked about that. So why do we box and unbox? What would be an example of something where we would box and unbox? Inheritance. What it means, when to use it. I might give you two classes, and you would tell me whether you'd use inheritance with them. For example, if I said coach and player, would there be an inheritance between coach and player? Maybe? Okay. Maybe. How could I fault you for maybe, right? But you got to clarify that. How would you set up the inheritance between coach and player? Very good. That would be an acceptable answer, to say that coach and player probably wouldn't inherit from each other, right? Because a coach is not a player is not a coach. But you could have a team member class, right? And not necessarily a team, but a team member class. And say that a coach and player, a coach is a team member, a player is a team member. And the trainer, the equipment manager, all those are team members. So you could do that. But that would be in a good example. And the main force for that is you apply the ISA test. Is this an example of that, or is that an example of this? So that would be an acceptable answer. And I don't give multiple choice questions. All these questions are what I call short answer. And just so you know, my definition of short answer is like a few sentences. All right? So if you were to write for that question that for inheritance of coach and player, that both the coach and player could inherit from a third class, a team member class, that would be an acceptable answer. If you said no, a coach and a player don't inherit from each other, because a coach is not a player and a player is not a coach, I would also consider that an acceptable answer. So that's one of the reasons that I give these is you don't just give your answer, you give some reasoning behind it. And I can see based on the reasoning behind it whether you really understand it or not. All right? writing functions that throw exceptions. So first part of that is writing functions to understand how you define a function, what are the parts of a function definition, the so-called signature of a function, and then with the extra ingredient that they can possibly throw an exception. Yeah, but you have a lot of time. I think I give a couple hours, and there really isn't a lot of questions. All right. Be able to do simple GUI stuff. What I mean by simple GUI stuff is set the value of a label, add a button to a panel, that sort of thing. All right, be able to do that. So again, that's a program snippet. You don't have to design an entire GUI to do something, but have a panel, create a button, create two buttons, add the two buttons to the panel. Maybe the panel's supposed to be horizontal, oriented horizontal. Constructors and constructor chaining. What do I mean by constructor chaining? I'll bet you all know how to do it. Maybe you don't know the term for it. Yeah. Well, no, not really. Go ahead. Yeah, that would be one way to do it. Like, let's say, for example, you had a customer class, and inherited from that you had a nonprofit customer class. So there might be a one argument constructor for the customer that accepts a name. And then you would have a one argument constructor on the subclass that also accepts a name. And you would take and you would call the supers constructor one argument constructor and pass in a name. So in that case, you're chaining between a subclass and a superclass. That's one form of constructor chaining, where this any case where a constructor calls another constructor is constructor chaining. Another example of that would be, let's say we had an argument, we had two constructors for a customer. One that accepted a customer name, and one accepted a customer name and gross sales for a year. All right? So you could write, in fact you should write, if you have the two argument constructor, it should chain to the one argument constructor. No, the other way around. The one argument constructor would chain to the two argument constructor. So for example, if there was a customer that accepted name and sales amount, you called the one argument constructor, then pass it the name. You could call the two argument constructor and default the sales amount to 0, for example. All right? So it's any time where a constructor calls another constructor. All right? And you even get that with function overloading, which would be sort of related to this as well, that you should probably be aware of, function overloading. So in a nutshell, either calling from a subclass to a superclass, or when you have multiple constructors that accept different numbers of arguments, and you can chain to another version of the constructor that accepts a default value. That would be an example. All right, understand about objects and object pointers. Know what that means. Know how you create a new object. Know when you don't create a new object. Know what happens when you assign one pointer to another pointer, and so on. The classic example for this kind of question is to do something like this. I can create if the question was, how many customer objects do I have here? What's the correct answer? 1. Okay. Why is that? Well, because there's only one new. All right. The new is what creates the customer in this case. Are D and C the same object? Do D and C point to the same object? Yes. So if I said C dot set name to Smith, and then I said what would I get? What would it output? So if I set the name for C to Smith and I said D get name, what would it show? It would also show Smith, because C and D are the same object. So if I set the name for C, I'm setting the name on the same object that D is pointing to. So if I said D get name, it would also return Smith. Now be able to do that, but with more complicated examples, where we create objects and so on. Know when an object disappears. That's another good test. All right, when an object disappears. All right, deployment methods. We've talked about jars. We've talked about JSP and servlets. And today we're going to talk a little bit about Android, probably. All right. What are the advantages of these in terms of deployment? If I am deploying my application by distributing jars to all my users, do they need the JRE? What do they need installed on their computer? Do they need the JRE? What if I use JSP or servlets? Do my clients need the JRE? All those are fair game questions. So understand what the advantages are and disadvantages of these different ways of deploying an application. I mentioned also up here with constructor chaining, function overloading. Know why you do it and what it means. Questions for any of this? Going once? Well, you tell us. Have we done function overloading? What? Okay. Okay. What is function overloading? Okay, I think that's a step in the right direction. Does anyone want to refine that? Mm-hmm. Right. Mm-hmm. Right, right. So, for example, let's say I had a function say I have a function on a parallelogram. This is calculate area. Okay. I have a function called calculate area. And it accepts two arguments. And it returns an integer. And it's public. And I could say return arg1 times arg2. So that's how you'd calculate the area of a rectangle. You'd multiply the height times the width. Now a square is just a special version of a rectangle, right? And a square only has one side. The length equals the width. So I could overload this function to have calculate area that only accepted one argument. And what it would do is it would call calculate area and it would simply pass the value of the side twice. So that's an overloaded function. All right. We definitely did overloaded constructors, right? Because we had different numbers of constructors. In the student example, where you had a constructor for the student, you could give a name and a residency code, or you could just give a name and it would default the residency code to in-county. Function overloading is the same thing for a function, except instead of being a constructor, it's just a plain old function. Usually what happens is there's versions of the function with more arguments. When you call a function that has the less arguments, some of the arguments get defaulted. So like in this case, there's a function to calculate the area that accepts two sides. When you call the function with just one argument, you use that argument for both sides. So you default the two sides as being equal. So that's an example of an overloaded function. So overloaded functions have the same name, but they vary in terms of the number of arguments that they have. And typically in the versions that have less arguments, certain values are defaulted. Any other questions about any of this stuff? Boxing and unboxing. Okay. What does boxing and unboxing relate to? Go ahead. Yeah. Yeah. There's actually, for every primitive that there is, there's also a class that is like it. So for example, for an int, there is the class integer. All right? And the reason for that is sometimes you need an object reference. A primitive won't do. For example, in an array list. Array lists can only be comprised of object references. You can't have an array list of primitives. All right? So if I wanted to make an array list that had integers in it, I could not make an array list of ints because ints are primitive. So instead, I'd make an array list of integers. And all boxing and unboxing says is, and does is, that the conversion between an int and an integer is pretty seamless. So if I have declared an int x equals 12 and an integer y equals 36, and I say y equals x, it seamlessly behind the scenes converts x, which is a primitive, into an object, integer. And you don't have to explicitly go and cast it or call a function or anything like that. Likewise, I could do math and it doesn't matter. I could add an int and an integer and store the result in an int, or I could add them and store the result in an integer. It just allows you to seamlessly use the integer and int. Same thing with all the other boxes. There's a boxed class, sort of a wrapper class for booleans, for doubles, and so on down the line. So it's just a seamless conversion between primitives and the wrapper classes. Any other questions? All right. What I like to do then, the one to focus on that we spent the last few weeks on, we didn't really have too many assignments relating to it. I guess we did have one, that is the making of the jar, is understand the deployment methods. We've talked about 2 deployment methods so far. We could make a jar that we would distribute, and each computer then would have a copy of their jar that wanted to run the application. Or we could create a web application where the application was running on a web server and everyone accesses it that way. All right. Another way we could do it is we could actually create an Android application. And let me see if I can connect my laptop here. Oh, here we go. Let's go and let's open Android Studio just so we get a taste of this. Now, yeah, that might be better. People that are in the Android class, this might be horrifying for them, but there we go. I'm going to open an existing Android app. And let's see. This example of an address book. run this. Okay, there we go. And there it is. We can rotate. This is our virtual device that we can run it on. And this is just an address book where you can go and click the plus, put in someone's information, and save it. Okay? So we definitely don't have time to go over all the ins and outs of this, but sort of to give a preview of it. Java stuff, in Android applications, pretty much one screen that you present to the user at a time is called an activity. All right? So if we look at this, we see that there's a main activity that's sort of the main boss that's running the show. You can then split that activity into fragments. And fragments are like little pieces of the activity, little standalone components. So this list is an example of a fragment. And when I click this to add one, that's a fragment as well. All right? If we look at the activity, the user interface is controlled via XML. So you notice that the content view comes from the file called rLayout_activity_main. Each activity has associated with it some resources. That's what the R means. The R means that this is found in the resources. So if we look under resources, layout, activity main, there is the code that describes the user interface and is done via XML. So the UI is described via XML. All right? Which might sound challenging, but it's in a way it's similar to developing a web page, right? With web pages you use markup as well to develop the interface. You create HTML. All right? This, there's simply different pieces of it. We can look at another one of these. We have text views. And text views are views that you can go in and either enter data or display data. Let's look into Fragment Add Edit. We have edit text fields that allow us to enter data. The plain text field is used simply to display that. The rest of the stuff is Java code. It's Java code that integrates very closely with the Android framework and the Android SDK. So for example, there's something called a recycler view that allows us to easily manage a list like this, which can grow and shrink. All right? We will extend that recycler view in our classes, and this will allow us to take the built-in functionality in the Android framework and simply customize it for our purpose. So the whole idea is we don't reinvent the wheel. So instead of us writing a list that you can add stuff to and display, there's components built into the Android language. So half the battle of developing an Android app is understanding the components that exist in the Android framework. And then the other half of the battle is knowing the basic Java syntax and concepts to work with it. If a couple people in this class are in the Android, how would you contrast doing Android development with doing straight Java development like we've been doing in this class? Right. Yep. So you're essentially fighting those two things. All right. There's the basic Java skills that you have, plus a layer on top of that is understanding what tools are available in the Android language so you don't have to reinvent the wheel. You don't have to do everything from scratch. Because I could custom write a little code that would do a list like this. All right? But there's already a recycler view that handles that. And what's more, it's also useful if there are many, many items in the view and only some of them can be seen at the same time. It manages the memory and the resources so that you're not storing a million objects for contacts if only 12 of them are displaying. All right? And that's handled all for you. That's really the key in any language, all right, is understanding what tools are available to you so that you don't have to custom code pieces of it. Ideally, you want to use components that are built into the framework or built into the language to do stuff because those are probably better tested, they're probably more robust, and have more functionality than anything you could come up with. So there's absolutely nothing wrong with using the built-in components. Just like if you've done ASP.NET, there's a lot of components in ASP.NET that are built in. Well, using them is key to writing good applications in that. We could create a simple hello world application. So I'll set new project, create an empty activity. Sure, I'll call it my application. You can set a minimum API, and that will run on approximately 99.6 of all devices. There are versions of Java that can, or I'm sorry, of the Android SDK that can be maddening because sometimes there's inconsistencies and issues between them. And we can go and create this. And if you notice, all this does is this creates for you your initial activity. In this case, all the activity does is it displays the layout main, which is in here. Oops. And displays the Hello World app. And then that's all that does is display the Hello World app. One nice thing about Android is there's a place for you to put all your string constants, which allows for real easy localization of your application. So if you wanted a Spanish language version of your application, all you would have to do is go and change and create a different string file to say, use this string file if the device's language is Spanish instead of English. So all your string constants that are used in displaying things exist in just one place, which really makes it easy then because you just have to change it in one place then, and you can automatically, your language will be translated into that language just by, all you have to do is supply the translation for all of your strings. You could use other resource qualifiers too. One of the big differences between the Android world and the iOS world is that in the iOS world, there's only a handful of devices you have to worry about running on. There's a certain number of iPhones, certain number of iPads, and that's it. Whereas Android, there's a full range. Many manufacturers have many different devices of different size. There's Android wearables. There's all kind of things. And so you can create resource files to say, hey, use this file if you're on this kind of device. Use this file if your screen is bigger than this, if it's smaller than this. And that allows you to sort of customize it to that. This is something I definitely would suggest you to try, give a shot at. There's a lot of good tutorials online. Also, CISS226 is the introduction to Android development that you can look at taking. Are there any questions about this? Again, we've talked about this at the end of class, like these are different deployment methods, but it's not like you write an entire application and say, well, I want to make it an Android application, right? It has to be something you have planned from the beginning. Or I'm going to make it servlets and JSPs. Or I'm going to make it and distribute jars. That's like an early design decision you have to make, is like what form your Java application will take. Questions? All right, Wednesday will be a work day for us. So go right to the lab, and there'll be a chance for you to work on whatever assignments you have outstanding. If there are no questions, we'll see you up in lab.